Good day, my amiable viewers. You are welcome back to my channel. As you already know, my name is Israel Gwai. In today's discussion, in today's teaching, we are going to consider a topic under organic chemistry we call isomerism. Please, after watching this video, do press the like button, also subscribe. Also help to share it. God bless you. Now, under organic chemistry, like I said, we are going to have a look at isomerism. Under this isomerism, we are going to look at some areas of it. Remember, we have several types of isomerism. You have the structural isomerism, you have the geometric isomerism, in which case we look at the cis and trans. We also have the optical isomerism and so many others. However, for this topic, we are going to have a look at structural isomerism, where we deal with structures. So, under this structural isomerism, there are usually three areas where the examination bodies normally bring their questions. The first one, the isomerism considering butane. You know, we have butane. In butane, you have the general formula C4H10. And you also know that butane have two structural isomers. The two isomers that are possible, you have two possible isomers of butane. So let's consider them. Let's say the first one, just the straight line, the linear structure. Remember, the bond will be attached to carbon atom. So this is normal butane. Then you also have another type in which you put a substituent. So this kind of structure is known as isobutane or isomer of butane. So these are the two possible structures of butane. But the impact name of this compound, you can start counting from anywhere, is 2-methyl propane. Then we can also have a look at another type which has 5 carbon atoms. We call it pentane, C5H12. Pentane has 3 possible isomers. Let's have a look at them. The first one, we just draw the straight line, the linear type. Introduce your hydrogen atoms and make sure the bond, as I said earlier, is attached to carbon atom. So this one is the normal pentane. You can have another one. You see, we have 4. If you put it here, when you stretch, it comes straight here. So you decide to do the first one. Therefore, let 1-methyl group blocks it from the other side. So it will not be able to stretch out to form the original linear structure. So you can see that this is another structure. This one you can start counting from here because it's nearer to the substituent. You call it 2-methyl butane. We have the last one, which comes like this. Good. Ensure you always count the number of hydrogen atoms to ensure it's accurate with the structure. Let's start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So like we said, this is C5H12. So these are the 3 possible isomers of pentane. But the last name is, you see, you can start counting from anywhere. 2,2-dimethyl propane. These are the names. First one is normal pentane, that's straight line. 2-methyl butane, where you already have a substituent or branch. Then 2,2-dimethyl propane. So let's have a look at the other one, which appears to be more tedious than the rest. However, it can be surmounted. And that's the last one they expect you to learn in your syllabus. Because as you go down to hexane, and it becomes more and more complex. That's why they prefer you to stop at hexane. So let's see hexane. C6H14. This one has 5 possible isomers. So look at how it goes. The first one, You just draw the linear structure or straight line 1, 2, 3, 4, 5, 6. Just introduce the hydrogen atoms at the appropriate positions, attached to carbon, not attached to bond or attached to something else. So you can see it. This hexane, normal hexane. Let's see another one. You can have something like this. You see, I have the fifth one. So just put a structure like this. It's substituent. It are not changing from the original, from the linear type. So this is an isomer of hexane. In this case, we count. Start counting from 1, 2, 3, 4, 5. 2-methyl pentane. So let's have a look at the third one. Make sure they are not the same. Actually, how you know they are not the same is by considering, looking at the naming. Let's spread it out. 1, 2, 3, 4, 5, 5, 6. Okay. All be very sure what you are doing. So you have hydrogen here, you have hydrogen here. At the end of the day, count it and ensure the number of carbon atoms are 14 in number. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you see, you can start from any side. 1, 2, 3, 4. I mean the counting. You have 2, 3 dimethyl butane. That's the third one. Then let's see the fourth one. You can put one here and put one here. You can see it. So you count the number of carbon atoms. 1, 2, 3, 4, 5, 6. The number of hydrogen, let's start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this one, because the branches are closer to the right hand side, you start counting from the right hand side, just to give this substituent the lowest number. 3, 4. So 2 dimethyl butane is the name. Then the last one. Remember we said you have 5 possible isomers. You just put it at the center so that it's at the center. The number of groups at both sides are equal. The number of alkyl groups. And see, if you start from the center, this is an ethyl group, this is an ethyl group. So they are equal. So you can start counting from anywhere. 1, 2, 3, 4, 5. 3 methyl pentane. So these are the 5 possible isomers of hexane. These are how we can take for today. Remember, all this one, because they are dealing with structures, they are called structural isomers. And I told you, we also have other type of isomerism, like the geometric isomerism, in which case we are taking of the cis and trans, and also optical isomerism. Please, next class, we'll consider that. Thank you very much for watching my video. Please kindly like and also subscribe. Share it to your friends, please. Thank you very much. God bless you.